Hello, this is Dr. Mears, and today we're going to be doing Pascal's triangle and binomial expansion. And I do have to apologize because I think I need a new camera. I feel like everything is a bit fuzzy with the one that I've had, and I've had this one for a few years. So if it's a little fuzzy, I'm sorry. I'll look into getting a new camera. If you do have any suggestions about a good document cam, please definitely drop it in the comments section and let me know which camera I should go with. Okay, without further ado, let's do Pascal's triangle. So there's so much that you could do with Pascal's triangle. However, with the time that we have, I'm just going to show you how Pascal's triangle is constructed and then what we're going to use it for. So we're going to start off with the number 1. That's going to be our very top of the triangle. And then from there, we're going to branch out and we're going to do 2 more ones, 1 and 1. And we're going to start to follow a pattern. Ones are always going to be on the outside of our triangle. And then let me show you what's going to be in the inside. So I'm going to start with the number 1. To get to the next number, I'm going to add these 2 numbers together, and I get the number 2. And then I'm going to end with the number 1. Next, I'm going to start with another number 1. I'm going to add these 2 numbers together. 1 plus 2 is 3. I'm going to add these 2 numbers together. 2 plus 1 is 3. And I'm going to end with the number 1. Next, what I'm going to do is I'm going to start with another number 1. I'm going to add 1 and 3 to get 4. I'm going to add 3 and 3 to get 6. I'm going to add 3 and 1 to get 4. I'm going to end with the number 1. And as you can see, we're starting to have a triangle. There are so many patterns in this triangle. It is amazing. I really do wish we could dive into it a little bit more. All right, let's keep going. We're going to start with the number 1. We're going to add 1 and 4, which is 5. We're going to add 4 and 6, which is 10. We're going to add 6 and 4, which is 10. And 4 and 1, which is 5. And end with the number 1. And if you liked seeing those kind of V's put in there where the numbers go down to, there you go. We're going to go just a couple more lines. Starting with the number 1, let's add 1 and 5 is 6. 5 and 10 is 15. 10 and 10 is 20. 10 and 5 is 15. 5 and 1 is 6. And with the number 1. Hopefully you're getting the pattern. Maybe you can try the next line by yourself. Start with the number 1. 6 and 1 is 7. 6 plus 15 is 21. 15 plus 20 is 35. 20 plus 15 is 35. 15 and 6 is 21. 6 and 1 is 7. And with the number 1. So as you can see, we're starting to have a triangle that's getting bigger and bigger the more lines that we introduce and the more lines that we actually follow the pattern. What is this used for? Many different things. What we're going to use it for is binomial expansion. What do I mean by that? Let's try example number 1. This is going to actually help us multiply without having to do a lot of steps. So let's just take the expression a plus b to the 0 power. Now anything to the 0 power is always going to equal 1. Whether it's 4 to the 0 power, that's going to equal 1. X to the 0 power, that equals 1. A plus b to the 0 power, that equals 1. Okay, number 2. Let's do a plus b to the first power. Okay, a plus b to the first power, well, that we can just remove the parentheses. It's a plus b. That's it. To the first power just means it's just itself, and so it's a plus b. I'm going to use a different color now because the coefficient of a is 1 and b is 1. And we got 1 here. That's very interesting. Okay. Number 3, let's do a problem like we've seen before, a plus b squared. So we've been multiplying and we've been squaring expressions. And so let's multiply this out. In order to multiply it out, we have to write it times itself because that's what squared is. Squared means times itself. And then we have to multiply. A times a is a squared. A times b is a times b, or ab. B times a, we can write that as ab as well. And b times b is b squared. Okay, let's combine our like terms. A squared plus 2ab plus b squared. And in green, I'm going to write my coefficients. 1, 2, 1. I've seen that somewhere before, haven't we? 1, 2, 1. That is very particular. And let's also notice our coefficients. This is a squared. This is to the first, and this is to the first. So if you add these, it's 2, and this one's squared. That's interesting as well. Let's do one more. Let's do a plus b to the third power. Now, a plus b to the third power is a plus b times a plus b times a plus b. And we've been doing these. You've seen where we've been multiplying three expressions times themselves. And what we do here first is we have to do 2 at a time. Don't multiply them all out all at once. Do 2 at a time. We already know what a plus b times a plus b is. We already got it right here. So I'm just going to bring that down. A squared plus 2ab plus b squared. And then, nope, whoops, my bad, plus b squared parentheses. Okay, and then I'm going to bring this down, times a plus b, because I already did that, so I just moved it down. I got it from here, so I just brought it down. Wow, this is really blurry. My apologies again. And then this is a times b. Okay, so let's multiply, because we have to keep going. Okay, we're going to multiply a to the first, remember this is to the first, times a squared, that's a to the third, a times 2ab plus 2a squared b, because a times a is a squared, and I brought the b down, and then a times b squared is plus ab squared. I am going to run out of room here. I might want to rewrite this over really quick. I am so sorry, everybody. I just need to move it over. I want it on one nice, big, neat line for you. Okay, so a times a squared is a to the third, a plus 2a squared b, a times b plus ab squared. Okay, so that got my a done. Let's do b. Plus a squared times b plus 2ab squared plus b to the third. Okay, let's combine some like terms. Equals. Are there other a to the thirds here? Nope, that stays a to the third. Are there other a square b terms? I have one here and one here. So that gives me 3a square b terms. So that's out. That's out. Okay. Are there other a b squares? Yes, I have 2 here. I have 2 AB squares. That gives me 3 AB squares. And then that's out. Are there other B cubes? No, plus B cubed. Okay, some things to explore. Let's put our exponents in. 1, 3, 3, 1. I wonder where we've seen that before. And if you're saying, wait a minute, this is all coming from Pascal's triangle, you're right. ab to the 0 power is 1, right there. A plus b to the first power is 1a plus 1b, 1 and 1, 1 and 1. A plus b squared, okay, gives us a squared, 1a squared, plus 2ab's, plus 1b squared, right here. Okay, how about if we raise it to the third power? What's that going to look like? Well, we're going to have 1a cubed, 3a squared b's, another 3ab squares, and then 1b cubed. That comes from there. If we kept going, it would keep following this. So if this went to the fourth power, these would be the coefficients of our variables when we multiply. So interesting. I also want to point out the exponents and how they decrease and then increase. So if you look here, this is a to the third. In the next one, it's a squared. Then it's a to the first. Then there's no a. Oh, okay. How about if we start here? Do we have any b's? Nope, no b's. So 0, no b's. B to the first, b to the second, b to the third. So they decrease in exponent for A's and they increase in exponent for B's. And they always add to 3. Watch this. Here's 3, okay? What's 2 plus 1? 3. What's 1 plus 2? 3 and 3. So they always add to 3. It's so neat, all of the different patterns that you can find. So really, you don't have to go through all of this. This now does not have to be done. We can jump from here all the way down to here just using Pascal's triangle. Okay, there's going to be a couple different types of questions that I'm going to ask you for this. And I just wanted to show you in your notes, I did give it to you all expanded out, and it does, I'm very sorry that it looks blurry here. I went all the way to 5, and I expanded it all out. So you can even see here, this is 1a. I'm going to rewrite this over because this is interesting. This is a plus b to the 5th, so that you can see a little bit clearer. This would be 1a to the 5th plus 5a to the 4th, b to the 1st, plus 10a to the 3rd, 5, 4, 3, b to the, you got it, 2nd, plus 10. Okay, what happens with our a? You got it, it goes a squared, b, yep, b to the 3rd, plus 5a, b to the 4th, plus 1b, you got it, to the 5th. So here we have 1, 5, 10, 10, 5, 1. Okay. Exponents 5, 4, 3, 2, 1, none. No b's. B to the 1st, b squared, b to the 3rd, b to the 4th, b to the 5th. There we go. We have our patterns, we have our exponent patterns, and we have our coefficients. Now let's see our examples. I just wanted to do one where there's a little bit longer for you so that you can see. And we're going to be using this too. Okay, moving on to our examples. Number 1 says find the third term in the expansion of 3 plus xy to the 4th. So we're looking for the third term, and we're looking for x plus y to the 4th, just so that you can see it a little bit better. X plus y to the 4th. Okay, so we're going to be going to the 4th power. So when we look on our table here, remember, this is to the 0 power, to the 1st power. This is squared, 3rd power, 4th power. So we're looking here. We need the third term. So this is the 1st, this is the 2nd, this is the 3rd. So this would be the coefficient. So we know it's going to be 6. And if we did write it out, let's write it out. If we wrote it out, first we're going to have, and we're going to look on the other side here. First, we're going to have 1a to the 4th. I'm going to write it 1a to the 4th plus 4a to the 3rd b, because remember the exponents decrease, plus 6, here we go, a squared b squared. That's our third term. We don't have to go any further, so it's going to be 6a squared b squared. Do these add up to 4? Yes, that's a check. Here's our coefficient in front. Now, we don't want a and b, so what are we going to have to do? That is a, and this is b. So in order to get the third term of this, it's not going to be 6ab, it's going to be 6x squared y squared. So I just exchanged, instead of a, I put x squared, instead of b, I put y squared. That's all I did. A became x, b became y. This is the third term when we expand it. I didn't have to multiply. That was it. We found it. Okay, what's next? Let's find the second term, okay, of 4x minus 1 cubed. All right, so let's approach this a little bit different. Let's not go to the term yet. So let's not go to the Pascal's triangle. Let's just decide this is going to be a, -1 is going to be b. And some people think that's the tricky part because you have to make sure you're pulling those out, and that negative goes with that b now. That's -1. So just be careful when you're pulling the sign out. All right, so it's cubed. So we're going to look at the Pascal's triangle. It's cubed. So we're looking here. And they want the second term. Second term. So here's first term, here's second term. I know the coefficient's going to be 3. All right. Now, for the second term, let's look over here in the expansion. Here's the third. We have 1a cubed, that's the first term, plus 3a squared b. I'm going to actually write that out here. 1a cubed plus 3a squared b plus 3ab squared plus b to the third. All right, so they want the second term. So that's a second. We already know that starts with 3. All right, a squared. So what is our a? Our a is 4x. So 4x squared. Please notice how I'm using parentheses. I remember in a previous video, I said, please get used to using those parentheses because this is where it comes in handy. We're going to have to square both the 4 and the x. All right, and then what's b? Times just b, so times -1. So we have some things to clear up here. So this is going to equal 3 times the 4 squared and the x squared. So this is really 16x squared, and we still need to multiply it times -1. So we can now multiply all of these numbers. We got rid of the square. We can multiply 3 times 16 times -1. And we are going to get, when we multiply 3 times 16 times -1, -48x squared. And so that is going to be our second term. Now you might say this is a little bit more complicated than actually multiplying it out, but if you know the pattern, if you're able to remember that we have to use our parentheses when we pull our a and b out, it's going to save you time, and it does take practice. So just be careful. We got the 3 from Pascal's triangle, a squared, 4x squared, so 4 times 4 is 16, x times x is x squared. B is -1, and then we multiplied it. Okay, the next thing that you're going to have to do is you're going to have to expand it completely. So we're going to have to expand x plus y to the 4th completely. And you can multiply it, but when you multiply it out, we did the 3rd power, and that was a lot. So multiplying it out, you would be multiplying x plus y times x plus y times x plus y. This is a lot to multiply, everybody. So that's why Pascal's triangle comes in so handy. We just need to pull out what a and b is. We don't need to multiply. We can say this is our a and this is our b, and then we can use the pattern. So we know that the pattern is going to be 1, 4, 6, 4, 1. So let's put that in. 1, 4, 6, 4, 1. Okay. And so this first term, we know it's to the 4th, so that a is going to be to the 4th, but our a is x, so it's going to be x to the 4th. That's our very first one. X gets to the 4th. Plus, okay, what happens now? This goes down, x to the 3rd, okay? But we need y to the 1st. You got it. Okay, plus 6, what do we now know? This goes down, x squared and y squared. Perfect, because if once this one goes down, this one goes up. They're always going to add to 4. Plus 4, okay, x 2 to 1, all right, y to the, you got it, 3rd, plus, no more x, we're all out of them, y to the 4th, and that's it. That's it. We didn't have to do any of this multiplication. This is our answer. Okay, so you would say, wait a minute. That's great. This would probably be labeled as one of your basic examples. what does an intermediate look like? And that's our last one for today, is the intermediate example. All right, here we have our intermediate example. I'm going to write it out. 4x minus 5y to the third. Okay, that's much better for my blurry camera today. I apologize. Okay, so we have to the third power. So let's write this out. So it's going to be 1, 3, 3, 1. And you can have this. We can even make a poster of it. We can go up to 10 if you want. Absolutely fine, so you have it. You do, once you use it a lot, then you get used to it. Okay, this 4x, this is A, this is B. We are going to have some parentheses, which is, hopefully I spread them out. All right, so it's going to be 1 times, we know A is going to take that one, so 4x to the third. So notice that that whole component is A. It has to be raised to the third power. Okay, plus, what's going to happen to this one? Yep, it's going to get brought down one exponent, so 4x squared, times, and you got negative 5y is going to pop in. Okay, that's really to the first, remember. Okay, plus, what's next? 4x, that goes down to the first power. If you like to write your ones in, that's fine. What's going to happen to negative 5y? It's going to do negative 5y squared. Okay, plus 1 times negative 5y, no more 4x's, to the third. So that goes up 1. All the exponents do add to 3, so that's a check. This one does decrease, and this one, the B's, does increase. Okay, we have some cleaning up. So if you can get here, that's wonderful. Now we just need to take it to that next step. Let's clean things up a little bit. So that means we're going to need to do 4 to the third power and x to the third power. And so so it's going to be 1 times 64x cubed plus 3 times, now we're going to need to do a 4 squared and an x squared. So 4 squared is 16, x squared is x squared, times negative 5y, okay, plus 3 times, that's to the first, 4x, times negative 5 squared is positive 25, y squared is y squared, plus 1 times negative 5 to the third is going to be negative 125. Y to the third is y to the third. So first I took care of all of the exponents and I rewrote it over. Notice I kept those coefficients in front. Now I can just multiply. 1 times 64 is 64x to the third. 3 times 16 times negative 5 gives me a negative 240 x squared y. So that plus, because I'm multiplying by a negative, now just changes to the negative number. Okay. Then 3 times 4 times 25, positive 300 x y squared. Okay. Positive 1 times negative 25 minus 125 y cubed. Here is our answer. That is the work that we had to do. To multiply this out, we would have had to multiply 4x minus 5y times 4x minus 5y times 4x minus 5y. And instead of having to do all of that, we were able to use Pascal's triangle. You just really have to be careful. You have to put things in parentheses and do it step by step so that you're not mixing up your numbers and you're making sure your signs are coming out correctly. So this has been Pascal's triangle and binomial expansion. As you see, we used it to expand. I hope it helped.